Hello friends, this video on application of derivatives part 19 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 18. Let's take some graphs to understand maximum and minimum. And please note, with graph I can find maxima or minima even for non-differentiable function. So you have any function, you just plot the graph and you get the maximum and minimum. You have this function, you plot the graph and you find the maximum. You can just see the maxima. You touch the point like this becomes FC and this point is Fx. Similarly, you have this graph, you can just observe the minimum value. This guy is FC and this guy is C. Similarly, this graph, just by looking at the graph, you can find the maxima and minimum. But with this, the observation is, first thing is, we can find the maxima and minima of a function at a point even if that is not differentiable using graph. Also, if you see with these two, in this case the maxima occurs at turning point. Correct? Turning point. Here also turning point. This guy is not turning point. The maxima and minima is at end point. Correct. One more example, I'll take the graph. If this is the graph, fx is equal to mod x. So if you see the minima and maximum occur here, and this guy is not turning point. This guy is nothing but a point, non-differentiable point. Correct. And if you see for this graph also, I'm able to find the maximum and minima just by looking at the graph if I have the graph. So two things to note. One is we can find the maximum and minimum of a function even if it is not differentiable using graph. Second thing, the maxima and minima can happen at turning point, end point, or non-differentiable point. We'll take more theorems on this which will explain that this happens, but just logically, if you can see, the observation we have is the maxima and minima happens at turning points, end points, or at the point which is non-differentiable, because in this case it is not differentiable and the minima is happening here. Correct. So let's summarize the observation. Every continuous function on a closed interval has a maxima and a minimum. So if I have a continuous function, something like this, on a closed interval, let's suppose this is minus 1 to 5, right? It will have a maxima and a minimum. Even if this is the case, let's suppose, if you see, this is minus 1 to, let's suppose, 8. This guy also has a minima and a maxima. So if you take any closed interval and continuous function, it has to have maxima or minima. Whether it is a turning point or end point or the place where it is not differentiable, that's a different thing. But a continuous function in a closed interval will have a maxima and minimum. Second thing, a monatomic function assumes its maxima and minima at the end points. For example, this is my monatomic function, it keeps increasing. Such kind of function will take maxima and minima only at the end points. In that case, since there is no turning point and it is monatomic, so it is differentiable everywhere. So the two other clause which I had was turning point and non-differentiable points and end points, right? For general, we have 3 points where we can have maximum and minimum. For a monatomic function, turning point is not there and non-differentiable point is not there. The only point where it can have maximum and minimum is end point. For a continuous function, since it is differentiable always, this clause is gone. So it can have maximum and minima either at end points or at the turning points. So that's how it is actually. So for any function, it will have maxima and minima at either end points, turning points, or non-differentiable point. Just understand or learn this, because that is the critical part here. For any function, the maxima and minima can have, I can show you, or I have shown you actually, at either the endpoints turning points, or if I have function like this, right, fx equal to x mod, this is a non-differentiable point. So non-differentiable, I'll write once again because that is critical. Non-differentiable turning point and endpoints. And at these points you can have maxima and minima, and these points are called critical point, because the points where we can have maxima and minima are called critical points. So if this is clear that the critical points are one of these points, non-differentiable points, turning points and endpoints, let's now understand the concept of local maxima and absolute maxima and minima in little detail. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.